Okay, so now let's start discussing about variational method as an approximation method to find out the solution for Schrodinger equation at some particular cases. So this method is also called Rayleigh-Ritz method. So what we need to do is we need to solve h psi equal to e psi. This is our time independent Schrodinger equation. So to apply variation method, we must have a non-Hamiltonian and state or the iron value in this case may be unknown. So these are the things that we need to find out after solving this equation. Okay, so the natural way of doing is just solve this equation. But whenever you have trouble, you have to use the approximation scheme. So what is this variational method? We have seen in classical mechanics deriving Euler's Lagrange's equation of motion from principle of least action or principle of stationary action. So in this process, what you have seen is you have identified a function called action integral, and any variation of that function, as it is a stationary function, any variation of that function is going to be zero. So this is a principle of least action says any variation of the quantity called action is going to be zero. So this gave you your Lagrange's equation of motion. The same way, the same principle, we have some sort of a function. If the variation of that quantity is being zero, that will give you Schrodinger equation of motion. So we identify that quantity as the expectation energy. Delta E equal to 0 here is called the variational equation. Variational equation. Okay, so our aim is going to be to find out energy expectation value, and uh, in all the value that you're obtaining is not going to satisfy this particular kind of condition, and we have to find when the condition that delta is equal to 0 is getting satisfied for that particular function, or when that E is getting stationary, and that corresponds to our Schrodinger equation. So first, what is this E here? Is the expectation energy, it is psi h cap psi divided by psi. This is your expectation energy, and if for a normalist state, this is going to be psi h cap psi. The denominator will not be there. Okay, so you can see that E is actually depends upon psi. H cap is an operator, so it depends upon psi. It's a kind of function of psi. Varying this function will change the energy value that you're obtaining here. And now when we are framing the problem, we have said that this is applicable for the problems where we have a non-Hamiltonian and unknown states. So without knowing the state, how do you find out this quantity? Well, to find the quantity, obviously we must take some trial wave function. So the psi here is trial. Okay, psi is a trial wave function. So the trial wave function must have, it's a trial wave function, it's not the original wave function, that must have some adjustable parameter and that parameter we will fine tune that parameter in such a way that produces this kind of a condition. That's what we are actually going to do. We will vary the trial wave function and the uh, adjustable parameter on that wave function, something like let's write psi alpha, psi of alpha or something, where this alpha is the adjustable parameter. So what we have to make is we have to make the this quantity stationary uh, by adjusting this adjustable parameter alpha. So this is going to be an approximate solution, uh, and the solution is going to be more accurate when you are taking a very suitable wave function. That means the wave function that is kind of close to the actual solution. If you are able to guess at the first place itself, you'll be having a very good approximation as a result. Otherwise, it depends. The quality of the approximation depends upon the quality of your wave function. And in most cases, for your examination, the trial wave function will be given to you. So you just have to investigate this quantity and find out the variation over that. Uh, and yeah, find out the expectation, no, energy, approximate energy and value, and the wave function corresponding to that. So that's a way of proceeding with that. So you will be getting to know the picture much more detail when we are solving the problem. But before that, we have to just show that this delta E equal to 0 is actually giving you the Schrodinger equation. So what we have to do next is to find this quantity delta E equal to 0 that corresponds to Schrodinger equation. To calculate this quantity, uh, I know what is E is nothing but psi h cap psi divided by psi. Okay, so this will give you something like E psi psi equal to psi h cap psi. Now the idea for me is to find out this delta E. So I just have to take the variation of this expression. So when I take the variation, it will become delta E into psi psi. Not just that, variation of cat psi 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 will come with your E, and also you have your psi delta psi E, which is equal to delta psi h cap psi plus psi h cap delta psi. Okay, now I can combine these two terms, because you see I can, this is just a number, I can just insert it in the middle of the to make it kind of an equivalent form. So if I do that, what I'll get is just like delta psi h cap psi. Both of these uh, both of these terms are having actually the same bra and same cat, so you can write it together. In the same way you can write these two together. Okay, I'm keeping only this term in the LHS now. It will become delta E psi psi equal to this will become delta psi h cap minus e psi plus second term will be psi h cap minus e delta psi. Okay, so this quantity is going to be 0 according to our variational scheme. So this is something that we have to make 0. That variation is 0. This quantity is 0, which indicate that RHS whatever term is there. And you see the terms here, uh, delta psi h cap minus e psi, and here psi, the same operator, delta psi. It's just like an addition of two complex conjugates. So what happen if we add two complex conjugates, a plus ib, a minus ib, will become 2 times a. The complex part will be cancelling. So this quantity only will be having the real part of whatever. So this is nothing but the real part 2 times. 2 times the real part of delta psi h cap minus e psi. Okay, 2 is there. Okay, now something that I'll call this negation number 1, and I'll put another variation to this expression, and that the second variation is delta. Okay, I call this delta psi prime as my second variation, and that second variation is connected with the first variation like this, I delta psi. So it's the variation is in the complex axis, not on the real axis. Okay, now what is the change the first term is going to have in the LHS? Whatever term we have is having delta E into psi psi. So delta C is only having, or delta E is only having the real number. It's a real number. There is no this factor coming in. There is no change for that term. This is going to be equal to your delta psi prime h cap minus E psi, okay, plus another term is psi h cap minus E delta psi prime. These are the two terms. Now I know this quantity delta psi prime is nothing but I delta psi. So I just have to take that complex number which is remaining outside. I am just going to substitute here. So this is going to be delta psi coming here and then I coming out. And I coming out from the bra is going to be minus I. And then I also will come from here, but that is going to be the whatever form it is. So this term, as the minus 1 coming out, this will become negative. This quantity is 0. Again, this is 0. This quantity will become minus, and delta psi h cap E psi plus second term is 1 I will be there. Here also I will be there. Psi h cap minus E delta psi. This is again like a plus ib minus a minus ib sort of form. So 2 minus sign will come, that will become plus 2ib. or plus or minus depending upon which order you are subtracting. Anyway, that really does not have any meaning because RHS is 0. Okay, so what we have is 2 times imaginary part of that function. So yeah, this is 2 times imaginary part of your delta psi h cap minus e psi. Okay, this quantity is 0. So this is equation number 2. Now what we have, equation number 1 says that the real part of this quantity is 0. 2 is not required. Uh, this real part is 0. Here we obtain that the imaginary part is 0. So that means the entire function is nothing but 0. So delta psi h cap minus e psi is equal to 0, or from this you will immediately get h psi equal to, you can move this e psi over RHS, which will implies you h psi equal to e psi, and that's your Schrodinger equation. Okay, so what we have done now is we have taken delta E is equal to 0, and we have shown that it is equivalent to your Schrodinger equation of this particular form. Now let me just take this psi as a combination of states like n, an, phi n, like this. If I want to find E, what will I get? E is nothing but psi h cap psi divided by psi psi. Okay, so h cap psi, that will produce an energy value. Okay, you can substitute this quantity over there and it will just produce exactly whatever state it corresponds and an energy and value. So this is going to be something like sigma n. an is there, and the complex conjugate will be multiplied, and it's nothing but an square, uh, and you will be having an en coming because of this h cap operation, divided by sigma n an square. Okay, so this is your energy expression that you are obtaining for a particular choice of psi. Okay, so what is the speciality of this E? Oh, there is nothing special. I can claim like this: E greater than the ground state energy here. I mean the least value of n. So that I call as ground state. Okay. So for the choice of this psi, I calculate this quantity and I obtained a lot of En number, and whatever is the lower energy state, I call that as a ground state. Okay, let us take 10 states are there, and the first state I call it as ground state, and my claim is that my energy is always going to be greater than that smaller energy level. There is nothing wrong in saying that way. It is true because that is a lower energy level. Okay, now you think that if there is no any other energy in states, only this is the state that we have. In that particular case, this inequality can become equality, provided only we have a single state over there. Okay, so the whole idea is that whatever energy that you are obtaining for the choice of our psi is going to be always greater than or equal to the ground state energy. So this is actually what leads to our approximate answer of energy. uh, how do that give an approximation for our ground state? Well, you uh, calculate energy for a particular choice of your wave function, and you will be having a set of E1, E2, E3, etc. E1, E2, E3, etc. Something you will be getting for a particular choice of psi. Then you will adjust your the adjustable parameter of this psi, and you will be having another set of E, uh, well, A, E, B, E, C, etc. And you'll be having pretty much different values of E. Like you can put it like that. E. Uh, Further, you have to actually put two coefficients. Then only you can write it like that. Anyway, you understand the point that for different choice of the variation, varying parameter, adjustable parameter that we have different set of energy and value, and all of them will be having a smaller energy and value. Okay, so if you are able to find out an E among all of these things, which is kind of uh, small, you choose that value as your E. Suppose if I'm summing over this, I'm getting 5 times E1, 2 times E1, and I got this as E1. If that is the case, I can choose even or the lower energy level which is possible for this particular quantity as a good approximation for my ground state, right? Because I know energy I will be getting, whatever energy I will be getting is obviously greater than the ground state, but at this point I have the least value for that energy, and that is close to my ground state energy. So this is the way we do our analysis. We will just uh, find out this quantity and we will minimize that quantity, and whichever time this is going to give you the minimum value of energy that is kind of close to the uh, ground state energy that we are interested.